Hi everyone, this is going to be the last of the videos in the Lecture 9 series of Testing for Association. And in this video I'm going to talk about discriminant analysis, when to use it and how, and I will make a few comments on conjoint analysis and how it is used, but in terms of how to do it, that is beyond the scope of this subject. I have made available a video that will show conjoint analysis. So discriminant analysis is a technique to analyze when a dependent variable is categorical, so when it's nominal or ordinal, and you have an independent variables that are interval, so Likert scales. So we can use this to classify groups or objects by a set of independent variables. So this is basically a statistical tool for determining linear combinations of independent variables that will predict group membership. So back when I said that we can live without a person's demographics because we can use their other survey results in order to fill in the blanks, discriminant analysis is one of these measures that we can do in order to fill in those blanks. So if we can determine, say, someone's perceptions of satisfaction or response to a their liking response to a how much they like a stimulus object, say a brand or an ad, we can then predict whether they are male or female, whether they live in a certain location, that sort of categorical data. So some of the applications in which discriminant analysis is used, it's used in product research in order to distinguish between heavy, medium and light users in terms of their consumption habits and lifestyle information. We can use it in image research to discriminate between customers who exhibit favorable or unfavorable perceptions of a company, product, brand or store. Advertising research to distinguish how market segments differ in media consumption habits, and direct marketing. So things like consumers who respond positively to marketing solicitations and who do not. So therefore you can target those who respond positively more effectively and more directly because you know some more relevant information about them. So if we know certain customer data, if we haven't done a survey on a particular sample and we find that customers who respond more positively to our brand or our taste predicted to be male, it means that when we go to do our advertising or our distribution, we can more easily target males than it is to target people who may not have seen your brand before. So this is why we use discriminant analysis. So the procedure is as follows. So I go to my Delhi depot data and we need to go to Analyze, Classify, there it is. Oh, and we need to do Hierarchical, Classify. Oh, no, we're doing Discriminant the first time round. So it is discriminant. Go double check. Our non-metric dependent variable that we're going to use is gender, so that becomes our grouping variable. We need to define how we have coded these groups. So in this case, because we're using different data, I'm sorry, the minimum is 0 and the maximum is 1. We can have more than 2 groups in doing discriminant analysis, it would simply be your minimum would be the lowest number that is in that variable. So it might be from 1, and the maximum might be 7 if you have 7 groups. But in this case, we're doing gender, so in the Delhi Depot data, it's 0 and 1. And our independents that we are going to use are the metric variables of X1, friendly employees, to X6, fast service. So we're going to see how these perceptions of these variables can predict gender. So we need to click statistics. We want to select means, univariate ANOVAs, and continue. And then we want to click classify and summary table and continue. And that's all we need to do, and we hit OK. So here is our output for the discriminant analysis. It is quite a lot of output in terms of doing the analysis. So I will try and make it more understandable by showing it to you in the slides. So the first thing we need to look at is the Wilks Lambda table. So this assesses whether discriminant analysis is statistically significant. So the same way that the F statistic in regression shows us whether the regression model is significant, in a discriminant analysis, the Wilks Lambda is what we use to see whether the analysis test itself is significant. So in this case, the Wilks Lambda is 0.317, and our p-value is 0.000, so which is less than our cutoff of 0.05. So our discriminant analysis is significant, so we continue with our analysis. Just as a side note here, you can also look at your Eigen Values score, the Eigen Values and the Canonical correlation. I have no idea how to pronounce that. In terms of the Eigen Value, the bigger the Eigen Value, the more variance that is explained between your independent variables and your dependent variable. And the canonical correlation is the effect size. So we square this, so to then say 68% of variance in our dependent variable is explained by our 6 independent variables. But we also have the classification results, which tell us that down the bottom here, that in terms of the assessment of the overall ability of the discriminant analysis to predict group membership, essentially 90% of male and female group membership is predicted by our 6 independent variables. So this is a very good result. How good this result is depends on the number of groups that you are trying to predict and the number of observations you have in each group to start with. So is it better than random? Tends to be a better, the higher the percentage is above a random assignment to groups, the better discriminant analysis test that you have. So the next thing we need to look at is what variables of our independent variables list are actually useful in predicting membership. So in the first test of this, we look at the test for equality of group means, and we look at the significance levels that are shown here. So we look at this final column, and we see that for X1, 2, 3, and 6, they are shown to be significantly different in terms of the mean score for males and females on these variables. and X4 and X5 are not significantly different. So at this point that we know that X4 and X5, excellent food quality and wide variety of food, are not predictive, do not predict group membership of males and females. However, we also then need to look at the standardized canonical discriminant function coefficients and the structure matrix. The structure matrix is the easiest to look at in terms of interpretation, so that's what I've listed here in terms of what to look at, but you can also look at the first table of the coefficients to look at the relative importance of the independent variables. But the structure matrix shows you basically the values in terms of goodness of predicting. I don't know, goodness that's not the best phrase, but it's what it's doing. So any value that is more than 0.3 on your structure matrix indicates that that variable is good at predicting group membership. So if we look at our list here, we can say that X6, and this is in either direction, it could be negative and it can be positive, it doesn't matter. So fast service X6 is above 0.3, X3 is, and X1 is. But if we look at X2, which if you look at our previous one, X2 was shown to have a significant difference between males and females, but in the discriminant analysis output we see that it is not a good predictor of group membership at only 0.28, which is below our 0.3 cutoff. So therefore we say that X2 is excluded from predicting male and female group membership. And then in terms of interpretation of what is being predicted by these useful independent variables. So the ones that we have been left with are X1, 3, and 6. So we then look at the group statistics which show the mean scores for these variables, and I have reconfigured these into a table that makes it much more easy to interpret. So the mean score for males and females on these variables suggests that females have higher scores on friendly employees than males. They have higher scores on competent employees than males, but males have higher scores than females on fast service. So we can then say, what we can then say is we can then look at these three variables, and if all the information that we have is that the on X1 and X3 they are higher than a male score, and on X6 they are lower than a male score, we can predict that this person is female. So discriminant analysis can then be used to say that if a person is female, they're going to have these reactions to this type of variable if we are going to then influence that kind of variable, and vice versa for males. So in the final bit of this video, I'm going to talk about conjoint analysis. So when the question is what are the most preferred combinations of products or service features, we need conjoint analysis is a very useful test to do. So it's used to estimate the value or the utility respondents associate with different features or attributes. So it assumes that you know what the important attributes are, and we need to design the questionnaire instrument in order to collect the information, collect the data in a particular format in order to allow conjoint analysis to be tested for. So it is very useful in terms of product image analysis and segmentation analysis. So I've linked to videos on the SPSS procedure and the setup procedure for how to create these questionnaires. However, because we haven't done it as part of any of the projects in this course, I'm not going to go into too much detail into how to analyze conjoint analysis data. So, in terms of setting up conjoint analysis, so before we do the survey, you need to decide on what options you are going to give, what alternatives you are giving, what are the attributes you are going to provide in those things, and how what type of measurement you're going to use on those attributes. So this is from a previous project, but we had a project looking at drones that were used for tracking animals on farms and in research projects that were interested in wild animals. So we have combinations of 3 by 2 by 3. So we have 3 alternatives by 3 attributes. So we have 3 by 2 by 3. Each combination becomes an option. Option A is compared to option B, and the respondent must choose which one they prefer. So what does this look like? It means that option A, I create one alternative, so where the price is low, the purchase type is for rent, and the number of animals that can be tracked is 100. Versus option B, where the price is medium, the purchase type is to rent, and the number of animals that can be tracked is 500. And I keep alternating these combinations of alternatives and their attributes, and respondents are given this series of 2 alternatives, and the respondent must pick A or B. And by choosing A over B, and then B over C and C over A, we can then use mathematics to determine which of the attributes is driving the preference, and how important that and at what level that attribute is most effective in determining someone's choice. So that is this format. There is another format that you can then have people having to choose ranking, whether A is better than B, which is better than C, but that is less common, and the mathematical analysis at the end is more complicated. So in terms of the calculations, this is covered in your textbook, or there is also a video that I have linked to in the slides if you would like to know more about content analysis. So this is all I needed to discuss with you this week when it comes to testing for associations. In next week's videos, we're going to talk about, and class, we're going to talk about tests for interdependence, where we look at factor analysis and cluster analysis.